Hey guys, this is Zaf and today I'm gonna show you how to simulate XADC IP. Actually, XADC IP is basically an analog to digital converter wizard that generates an HDL wrapper to configure the XADC primitive for user specified external channels, internal sensor channels, and modes of operation and alarms as well. Okay. So the features for that IP are analog to digital conversion, FPGA, temperature, and voltage monitoring. By the way, this temperature is basically the temperature of FPGA die, and it generates alarms based on the user set parameters, and we will see how can you set that parameters. Okay, and it does have other options like XZ Lite interface and XZ Stream interface and simple user interface, and other features are like easy configuration of various modes and parameters, simple interface for channels selection and configuration, ability to select and deselect alarm outputs and set alarm limits, and you can also calculate all the parameters and register values. So I'm not gonna tell you a lot of details about this IP, but the purpose of this video is just to show you how you can simulate this IP. Alright, so now let's just get started. So first thing I'm gonna show you is how to create a project and how to instantiate the IP using generator. Okay, so I already opened the Vivado here, and the version I'm using right now is 2016.4, and I already clicked on the click project here, and it just asks me like create a new project. Yeah, so just click on next and just put the name here. So I'm gonna put the name as XADC test. Alright, and I already selected the folder, so it's gonna create a new subdirectory here. So just click on the next, and yes, RTL based project, yes, click next. And okay, so the target language I am selecting here is a Verilog. So definitely it totally up to you. I mean, what language you want. I mean, the rest of your project, if it is in the VHDL, so just select VHDL, or if it is in Verilog, so just select Verilog. All right, so I'm selecting Verilog here, and the simulator language is mixed. All right, and I'm not adding or creating the files right now. I will create it later. Okay, so click next, and this is basically add existing IP. So we are gonna create the IP, so we don't have any IP right now. So click next. And constraints, I don't think so we need constraint for simulation, so just skip that thing as well. Click next. And for simplicity, I'm gonna select the Z board, but whatever the boards you have and whatever you are working on, you can select that board as well, but I'm just selecting the Z board evaluation. Okay, so I'll just click next, and everything is here. Is just a summary of the project, and just finish, and it will create your project for you. Okay, so here we go. We have a project, just a project, no files right now. So the first thing I'm gonna show you is how to find an IP in your IP catalog. So here we have a flow navigator, and in flow navigator we do have a project manager, and under project manager we do have an IP catalog here. So just click on that, and it will show you that small window here, and you can see we do have a lot of things here. All right, so there are two ways to find your desired IP. So actually I know XADC should be under the FPGA features and designs, so I can just open that folder, and here we have XADC, and we can just find that here. Okay, and if you know the exact name of IP, you can just type like just close that and just put like XADC here. It will automatically search for you and show you here. Okay, so this is the same thing. So just double click on that, and it will show you another window where you have to specify all the configurations. All right, so here we have a window that actually shows you all the settings. Okay, all right, so what we are gonna do here, first of all, I'm gonna tell you some basic details of the IP, and then we will instantiate the IP. All right, so the functional overview, or we can say the functionality of IP, is basically the XADC wizard is is available in Vivado IP catalog. Actually, it instantiate an XADC block configured to your requirements. All right. Using the wizard, you can explicitly configure the XADC to operate in desired mode. XADC wizard allows you to select channel, enable alarms, and set the alarm limits. And the most important thing is XADC supports three types of interfaces. Okay, like the first you can see here is the XZ4 Lite, and for your information, I'm not going to simulate this interface right now. Yeah, but we are going to simulate two interfaces. Here is the first is DRP, that is basically dynamic reconfigurable port, DRP, and the another is XZ4 stream. Okay, so we have three modes actually. All right, and the other features of the IP, as we already, I think we discussed, that it is basically analog to digital converter. It can give you FPGA die temperature and some voltages. We will see which voltages are there, and it can also generate alarms, and that alarms are basically you specified. I mean, you are gonna specify the limits. All right, and then it will generate the alarm. Okay, and the other things are like we do have some clocks in the IP. All right, so the clocking is basically we can like understand in very simple way, like the clock to XADC primitives is DCLK. All right, so when XZ4 Lite is selected as bus interface, this DCLK is connected to SXZ ACLK clock. All right, and hence the clock division factor must be programmed taking into consideration the SXZ clock frequency. All right, I know it's a little bit difficult, but if you are gonna use XZ4 Lite, you have to have some information about that. So I would really I would highly suggest you to get some details. Like all the details are in you can see here the documentation. Just click on that and product guide, and it will show you the PDF, so you can just go through that and get some details. Okay, and we do have a reset as well. Here you can see the reset here. So if we are gonna select just the DRP, so the reset is basically active, I guess low, and if you're gonna select the enable this, then it's gonna be active high, but I'm not sure. Just see that maybe I'm a little bit wrong there. Well, okay, so the next thing I'm gonna discuss here is again all the information here. So interface options, we already discussed that. You can select XZ4 DIP. The second thing is startup channel selection. So for simulation or for your design, what channel you should select. So you have to have some information about that. So I'm going to tell you a little bit about the channels. So the simultaneous selection means like you're going to have simultaneous channels. Like you can definitely monitor temperature, the voltages, and other channels, because you know the name implies simultaneous. And the second one is independent. Independent ADC is basically the mode that allows you to run the XADC in independent mode. All right, which means like XADC independently monitors the external channels, and at the same time it can monitor the FPGA voltages and temperature. Okay, all right, and then by default you can see here is a single channel, which means basically in this mode you can select only one channel at a time. All right, so just for your information, if you are gonna select this channel and just click on here, and if you're gonna select the here's not, where is that option, the calibration? Well, just for information, we will see that later. If in the single channel, if you're gonna select the calibration channel, then you cannot simulate the design because it doesn't support that simulation file we are going to talk about later. All right, and then we do have a channel sequencer, that is actually the another option under startup channel selection. Channel sequencer is basically choosing this mode allows you to select any number of channels to monitor. All right, and you can have the details as I told you before through the documentation. Okay, and the timing mode is basically two timing modes we have, the continuous mode and the event mode. So in the continuous mode, the XADC continues to sample and convert the selected channel or channels, whatever. All right, and in the event mode, this mode requires an external trigger event, and in this mode we do have two more ports, you can say, and that would be basically CUNVST or CUNVST clock. You can see here this one and this one. Okay, so this channel is particularly used like for external channels. I mean, whenever you are going to use external channels, then this mode should be used because this is event based, so you don't need to convert your whatever the signals every time. That is basically happen in continuous mode. Okay, so now we are going to talk about this XZ4 stream options. So if you are going to enable the XZ4 stream here, you will have the FIFO depth. Okay, so what is FIFO depth? I mean, why we care about FIFO depth? Actually, FIFO depth can be configured here, and this depth refers to the maximum depth of the data which can be written into the FIFO before almost full becomes high. So it also depends on your design. I mean, you should know about your design, like how much data is gonna stream. So it's totally up to you. All right, so and this is JTAG arbiter we're gonna talk about later, and this portion of the settings is basically for simulation, and we care about it a little bit. Analog sim file options here. So the first option is sim file selection. You can see here it's a drop down list. The first option is default, and the second two are relative path text and relative path CSV. So if you're going to select default, so XADC automatically generates a design file for you that is basically used for simulation purpose. And this design file I can show you, but you can just go through the project and under the IP folder, and you can find this design.txt file in the simulation folder of the IP. It will automatically generate it for you. Okay, all right, then if you are gonna select the relative path.txt, it means like you are gonna put your own file here. So if I'm selecting this relative path, so you can see it becomes red because I have to specify my own file here. That is basically .txt file. Okay, and if you do have a .csv file, that means like you're gonna select this .csv file, and XADC will automatically convert .csv file into the text file. And did you notice, like, if I'm selecting this default, this is disabled. Sim file location is disabled now. Okay, but if I'm gonna select this again, it is enabled. It means like now you have to put the path of the file, the name here and the path here. Okay, but for simplicity, we are not going to put our own file. We are going to use the automatically generated file Okay, so the design.txt is automatically generated file. So here we have no sim file location. Why? Because it will automatically generated in the sim folder of an IP and automatically be fetched during simulation. Okay, and this is the waveform type. So here you can select 4 types of waveforms: the constant, the sine, triangular, squared. It's just a simulation purpose, so I don't care about a lot about that. Okay, and when you are when you're going to select the sine, you can select the frequency and the number of waves. So first we have to select just a constant. Okay, all right, so this is basically the conversion settings here. So this is the DCLK clock frequency. By default is 100 megahertz. So if it's 100 megahertz, then it means like the ADC conversion rate is 1000 kSPS or 1 MSPS, and the acquisition time clock is 4. But I'm not gonna tell you a lot about that. You can just have the information from the documentation, and you can choose your own values if it's a different for your design. Okay, so this is the basic settings in the basic tab, and this is the ADC setup. Here you can, again, you have to read manual to set these things. I mean, you can deselect that and whatever, all of them, but I am not not gonna tell everything here because the video goes long. All right, so alarms here you can select which alarms you care about and what are the limits. So this is basically the limit that actually triggers an alarm. Okay, so you can just specify the limits for the alarm and the limits for the reset. Reset means like when the alarm triggers, so alarm when the alarm gets reset again. So you can specify these limits. So by default all the values are here, and you just need to select which type of alarms you need. So you can select this one as well. This is the voltage of BRAM, and here we have the aux alarm, VCG DRO, VCC P integer alarm, VCC aux again, user temperature alarm, over temperature alarm, everything is here. And here's because for like startup channel selection, by default it's a single channel, so we are just gonna see here in the single channel is just a temperature, and I mean just a single channel. You can select any of these things. So first for the simplicity, I'm gonna select the temperature by default, and here you can see the summary, and whatever you selected, here's the summary. Okay, so everything is here, you can see there, and I'm just gonna click OK. And to create this okay, yeah, all right, so it will definitely synthesize because we select that option. Okay, and you can see here is start running. All right, so now I'm gonna add a file to simulate. So first I need to create a design source file here. So next, and create a file and just put the name XADC test. Okay, and the Verilog and everything is like whatever we have with the settings. Okay, finish. Not right now, I'll do it later. And yeah, this is the XADC test, and again I'm gonna, for simulation, I'm also gonna add file here and create file and put the name XADC test and the test went. Okay, and finish. Right, okay, yeah, I'll do it later, and it is under the simulation. Okay, now I'm gonna just pull that file just for simplicity, just remove the comments, and you can see here we don't have any port right now, and here we have the IP. Yeah, all right, so from where I can just pull the template, so just click on the IP sources here and just click IP hierarchy, and here you can see there's a folder called instantiation template. Okay, so just open that folder, and you can have 2 files. One is the .vho and one is the .veo. So because if you remember, I selected Verilog, so I'm gonna pull the templates from Verilog file. Here we have the template. Okay, so I'm just gonna copy that template here, copy, Control C, and just put into my that file. Okay, here we have. All right, so this is the instantiation. So just put the name here, that is basically XADC INSP. Okay, so we instantiated the IP here. Okay, but we didn't specify the number of ports here. So what I'm gonna do here, just so paste it here again, and just this, and remove this because this comments basically. So I'm gonna stop the video here because I have to do all this thing manually, and then I can show you back here. Okay, all right guys, so I did that job here. You can see I just remove the lines, and actually the comments, these are actually all are these comments here. So I just use that comments as the port description. So one thing I did here, just notice that I just put the commas here, and don't put the comma after the last port. Okay, so now we can save that here, the Control S, and now we are gonna look at the simulation file. Okay, so just click on the hierarchy and go to the simulation sources. And one more thing, you can see here now the IP is under the XADC test, that is basically our main file. Okay, so well, just go to that db file here, and just for simplicity just delete that comment here, and here we have to instantiate our main file. Okay, so just, okay, this is the video, just close that one, and this is our main file, close that one as well. Okay, so this is a main file and we have to instantiate that one. Okay, so what we are gonna do, we have to instantiate that. So just I think it's again a long job, so I'm gonna stop the video here and I will do it and show you. Okay guys, so here I wrote whatever I have to write in the test bench. So you can see here in the test bench, these are the same ports, and you can see here these are the same ports. Actually I copied these from the main file. Here we have here, but here we define the input and outputs, and here the same ports, but I just removed the inputs and outputs from here. Okay, and one more thing, I here you do have the commas because these are the ports, but here I declared all of them as the internal signals, so I just replace comma by semicolon and make these clock and the reset as reg, not the wire, and you should know what's the difference between them. All right, so one more thing I did here is I created a clock, generator clock basically. So here I set the time as #5. That means like we are gonna have 10 time units clock period, and I also generate a reset signal here, and after 200 I just toggle that signal. Okay, and I also instantiated our main design. So here you can see the difference. Here I instantiated an IP, this is XADC. all right, but in the test bench I instantiated that XADC test. Okay, here XADC test DUT. all right, but the ports are not almost exactly the same. Okay, so this is basically the port association actually. Okay, this is not the name association, this is the port association. So I just use dot before every port here and use the commas and just connect this signal to the internal signal. So if I just click on that, just double click on that, and I can show you here, this is basically the internal signal here. Okay, that is basically 16-bit internal signal. Okay, so now I just for simplicity connected every port with the internal signal, but now we have to modify a little bit here, like the data, where the data just we are gonna put the data as a 16-bit 0, because we don't need to give that IP any particular data. Okay, and what about the address? You can have the document and you can just can have the details as well, I mean what that address is for. Okay, but I'm gonna put here an address actually that is basically what should I write, it's like this, and is basically 2 like 1 0, and you can understand why did I do that. And not 0, it's another curly bracket, and this curly bracket is also here. Okay, this is basically a concatenation. Okay, and the channel output. Okay, so this is basically here, so just copy here and put it here, because this channel out is of 4 bits. If I just double click on that, you can see here it's a it's a 5-bit signal. Okay, but the address is a 7-bit here. Okay, the address is 7-bit and the channel out is 4-bit. That's why I concatenated 2 bits with this, so that I can give a 7-bit address here. Okay, and all right, so this is the dan in, so I just make dan in as like ECO out. Yeah, here this is the ECO out. I just connect this ECO out with the dan in here, and this is basically that one. By the way, I think I should give you a little detail about why I am doing this, I mean why I'm connecting this. So I need to pull the ports details so that I can give you a little bit information about that. Where is the port detail actually? Okay, so here we have, so basically what is D in and what is WA in. So the DE underscore in is basically an input signal, enable signal for the dynamic reconfiguration port. Okay, dan in. So I just connected that dan in with ECO out, and ECO out is basically the AND of conversion signal output, which means like whenever the conversion is done, it creates a acknowledgement signal, or it creates a pulse, so that you can now read the data. Okay, so you can now enable actually to read the data, enable enable the IP, or enable whatever you can say is just to read the data. Okay, that's why I'm connecting that. And DW is basically the write enable, so we are not going to write anything, that's why I just pull it to 0. Okay, all right, so what other signals we have to care about is I think we are all done, or yeah, we can just, because these are also inputs, so just make them also 0, because I'm not going to tell you a lot of details about them, but you can just read the manual, the user guide, so that we can get the information, I mean why I just make them 0. Okay, and the other are alarms, and these are the outputs, so I'm not gonna change any of them here. So I think we are done here. Okay, so just save that and just take a try to simulate the design. Okay, and this is an error in the file, so I think I did a mistake anywhere. So let me find out where did I where did I do a mistake. I think something goes wrong here. Okay, let me stop the video and I can fix you and show you. Okay, Alright guys, so I did a mistake here. Actually, I didn't put that curly brackets here and here because I am concatenating it, so I forgot to write this one, but now I added that one, so you can see here there's no error. Okay, so I think we are all set to simulate our IP. Alright, so what I'm gonna do is just click on run simulation and run behavioral simulation, and let's see uh, we can get the correct output or not. Hopefully we should. Let's see. Alright, so here we have the simulation results, but you can see here is the simulation has high impedance thing. So it is because these are the main this file ports, and I just put in the simulation all the connections and everything. So what I'm gonna do here is I'm just gonna delete all of them here. Okay, and I just put that all the ports of an IP. Okay, and I just make a reset and just simulate gain. Okay, that's it. So we have this here. Just make a reset here, and still we don't have the value. Why? Because we don't it actually is not fetching the file automatically, the design file. So what we are gonna do is add the design file in our simulation sources. So just save that waveform. Okay, save as, yeah, and just go to the project manager again and just add the simulation source file, add files, just go to the IP here. The file is not here, so the file, I think it should be here. Yeah, it is here. So just fetch the file from here and just, yeah. Okay, so now we have the file, the design file here. Okay, so let's simulate again and then right. Okay, here we have. All right, so let's take a look now. Yep, so I think I need to simulate a little bit more. Okay, cancel. Yeah, so now we do have the value here. We have okay, so now you can see, I'm just gonna zoom that in. Yeah, here we have, you can see this is the D out. Okay, maybe I should change its color to yellow. Okay, and this is the channel out. Where's the channel out? Is this here. I should change this to this. Okay, so you can see, I think D out is not visible still, so I need to make the color maybe red. Okay, so this is the channel out. You can see the channel out is 0 0, so the temperature is ACC 0, and then the value, the next value, and this value, I mean this is basically the temperature value. If you convert the ADC, we do have a formula in the user guide. You can just use that ACC value and you will have 63 centigrade, because we do have a 63 centigrade in our design file. Okay, so this is the values, and here's the alarm. You see, here's the alarm because the value exceeds, and here the value is not exceed. So this is the simulation actually, so you can find out everything is here. But you see, this is the only data coming from the temperature sensor, nothing else. And here you can see this is the EC out. EC out means like the conversion is done. So whenever the EC out is here, it means like this EC out is connected with the DAN. So the DAN is basically to read the data. That's why after that the data is here. Okay, and this is busy out. Busy out means like maybe I think I should, yeah. So busy out means like the conversion is being done. I mean, it's busy. ADC is busy, right? So this is here, and so this is basically that. So after this busy signal, like from here, after that EC out is here, like the conversion is being done, and the another conversion is again started here, and the DAN is also like makeables here. Okay, and then your data is here after like 1 or 2 clock cycles, and then you can check other values. Okay, so this is for like a single channel, and if we are gonna have like VCC and other values, so what we are gonna do is just to select other channels. And what I mean, like just go to the IP and select like channel sequencer, for example, and go to the channel sequencer and what channels you want, like the temperature, the VCC, this and the this and this and this and this and other channels, whatever you want. Okay, all the channels will be there. Okay, so just make okay and generate again, and it will take a little time, but your design file also will be updated, I guess. No, I don't think so, it's not gonna update, but the thing is your simulation result will be changed. Why? Because now you would have more values in your channel output, not just 0 0, because 0 0 is for only temperature. All right, here we go, it's ready. So I'm gonna simulate the design again, just relaunch, yeah, save, and I should stop the video again. Okay, here we have. So just see what is gonna happen here is okay, the same value, and click more and stop. Okay, so here we have more values for channels. Okay, so you can see zoom out a little bit, not too much. So here we have a lot of values. 0 0 for the temperature, 0 1 I don't know exactly for what voltage is, 0 2 is also a voltage, 0 3 0 6 0 D, a lot of channels. Why? Because we do have a lot of channels. So these values you can convert these data values to their respective channels, but to read like which addresses for what, you have to read the user guide. I just know 0 0 is for temperature and the others are for voltages, so these values are basically exactly right, and whenever it's wrong, the temperature or the other alarms will get triggered. Okay, so I think we are good to go, everything is fine. So one more thing, I'm not gonna show you the complete simulation for XZStream, but yeah, I can just show you how can you do that. Just click on the IP and you have to just enable the XZStream here, and just set your FIFO depth, and then just if you want temperature bus, just click on temp bus and it will add another port, and if you want a JTAG just to monitor, or if other purpose, you can use that. So you can just enable that one as well. And one more thing, I guess I changed the constant to sine, but I don't think so it doesn't matter a lot. But yeah, first I did simulate the design with constant then sine, just to show you both, and then okay, so here you can just enable that and you will have more like ports, because this is now you're gonna have M access port, and you can notice that now we don't have DCLK under that, and the reset. And in that case, you should like the reset is because here, and the clock is, both clocks are here because these clocks are internally connected with DCLK. So when you click OK on that, just connect the DCLK with these two in the simulation file as well, and make the reset 0 to 1 to 1 to 0. Okay, so I think that's the easiest way to simulate the XADC, and after simulation you can just synthesize and you can use in your design, and that's it. Okay, so thanks for watching, and I hope you enjoyed the video and learned a lot. Thanks.